So that means now we can do problems like these, right? If I was to ask you to do cos squared 3x maybe. What I would do is I would use the same identity, same substitution, but I'm going to do half outside of, so I'm using cos here now. We've got 1 plus double this, cos 6x. Still pull the half out. Only this time we just have a different expression on the inside of our brackets now. Right? We can do this same as per normal. Yeah? So 1 on 6 sine 6x plus our constants. Not too bad. All right, Emily, how's this one different though? Bounds, right? It's a defined integral. Okay, not only is it a defined integral, angle inside here is a bit weird. I said that the trick was we double the angle inside here. What is the angle inside here? This is a half, right? You can, if you want to think about it, you could write that as half x. If the x on 2 is a little bit confusing, right? So all you're doing is, okay, we're taking this, whatever the coefficient of this is, and we're doubling it, right? So that would give me, when I apply this identity, right, I'm doubling this, so I'm going to get half outside of 1 minus sine, well, if I double half, I just get 1, right? So it'd just be x, yeah? And then that's with respect to x as well. Does that make sense? All right, so all we're doing is we're saying, okay, here's my sine squared x. What's the value of n here? Well, it's half in this case. I'm just going to double that. I'm just going to get 1, all right? And then you can go ahead and integrate that for me. Recognizing now, yeah, I can still take the half out, but this time, I'm going to use my square bracket convention so that I can actually integrate this with particular bounds. Keep in mind any kind of substitutions you have to make and things like that. Okay. Ah, should be cos, hey. Let's go back. You guys gotta call me out on this. Just checking if you're listening. So let's go back. We have a defined integral. So it should be, if we do the substitution, half outside of 1 minus cos x. And that was again, yeah, because n was half here, so we doubled it, and we just go. You don't, if you want to leave it in there, you mean this one here?
Yeah, just click on it right now.
Yeah, you can do that if you want. And you can just integrate it. Some people will actually integrate it with the half there, so that's fine. I just find it easy to factorize it out and then do it that way. Okay, then once you actually use the identity correctly, then you can integrate. Remembering that you do have bounds here now, right? Eva, do you want to finish this off for us? Do you want to? The opposite of that, exactly. It's opposite that, isn't it?
So you have x
minus 9. Good. And you got your bounds here. And always check by just differentiating, making sure it checks out. It does, right? And then here, right, it's just trig substitution. And these are nice values here.
It shouldn't minus cos x be sin x.
So if we differentiate this, how do we check? We can go back. X is 1 minus sin x minus cos x. So yeah, it is very easy to be confused, especially when they're like cyclical integrations like this, like because they all kind of relate to each other. So yeah, put that in your common mistakes list if you think that's something that you're going to do, right? Then we can go ahead and substitute. So pi on 2 minus sine pi on 2. And here, especially with trig, you really want to write out the substitution because if you ever have like a cos function, cos of 0 won't just be 0, right? So you always want to be writing that out. Here it ends up quite nicely, right? Because these are just all going to go away. Sine of pi on 2, let's just think about your graph, or you can use your calculator. Just going to be 1, right? So we're just going to end up with a nice little exact value going on here. We'll get half outside of pi on 2 minus 1. Questions about that? Yep. 2 more for you to try. And then I will...
When are we going to use this?
Great question.
You don't?
Maybe we should do an assignment where you guys find out for me and then you present them.
Actually, we're already doing a test and